Okay, hello everybody. Thank you for watching my video. So today we will be discussing about CIE AS level math past papers from February March 2020. This is for junior college student, but also can be solved by secondary for students. So let's get started. This is question number 7. The diagram shows part of the curve with equation y equals 4 sine squared x plus 8 sine x plus 3. Thus this is the curve, yeah, with this equation, where x measured in radians. The curve crosses the x-axis at the point A, thus crosses the axis here, and the shaded region is bounded by the curve and the lines x equals 0 and y equals 0. Thus this is the shaded region. This is bounded by this curve. That is the y-axis and this is the x-axis. Now question A, find the exact x coordinate of A, of this point. That is actually the x-intercept of the curve. Now at A, that is x-intercept of this curve, y equals 0. Thus this is 0. So 4 sine squared x plus 8 sine x plus 3 equals 0. Thus we will solve this equation to find x at A. Now factorization of this quadratic equation in sine x, that is 2 sine x plus 1 times 2 sine x plus 3 equals 0. From this factor we obtain sine x is minus half, and from this factor we obtain sine x is minus 3 over 2. Thus this is rejected because this is minus 3 over 2, that is minus 1.5, since the minimum value of sine x is minus 1. Thus this is rejected. Now continue with sine x equals minus half. Thus the value of sine x is minus, that is mean that the x lies in the third quadrant or fourth quadrant. Thus first we have to find the basic angle. Basic angle, that is shift sign this of this without minus sign, because basic angle is always positive. Thus shift sign half, that is pi over 6. Thus this is the alpha of pi over 6, this angle actually here, this. Now thus this is the x equation. Thus x from here until there, that is pi plus basic angle. Thus x is pi plus pi over 6, that is 7 pi over 6. Thus the exact x coordinate of A, that is 7 pi over 6. Question B, find the exact gradient of the curve at A. Gradient of the curve at A, that is equals differentiation of y with respect to x when x is 7 pi over 6, that is the x at A. Now thus first we have to find the differentiation of y with respect to x. This is the y, 4 sine squared x plus 8 sine x plus 3. Now differentiation of 4 sine squared x, that is 8. Thus to move front, 8 sine x times differentiation of sine, that is cos x. Thus 8 sine x cos x plus 8 cos x, differentiation of 3 is 0. Thus this is the dy dx, that is 8 sine x cos x plus 8 cos x. When x is 7 pi over 6, that is x at A, dy dx is 8 sine x substitute by 7 pi over 6. Dus 8 sine 7 pi over 6 cos 7 pi over 6 plus 8 cos 7 pi over 6. Now, to calculate sine 7 pi over 6, we can use the basic angle of the this axis, that is 7 pi over 6, and we know that the basic angle, that is pi over 6. Those sine 7 pi over 6 we can replace by sine pi over 6, but 7 pi over 6, that is in the third quadrant, sine in the third quadrant minus, that is why we have a minus sign here. And also for cos 7 pi over 6 we replace by cos of the basic angle with minus sign, because cos in the third quadrant also minus, plus 8 times cos 7 pi over 6, that is equals minus cos pi over 6. Now, for trigonometric ratios of the special angle, because pi over 6 is one of the special angle, can be obtained by using the right angle triangle. Thus, if we draw an accurate triangle, right angle triangle, this angle is pi over 6. If the opposite side is 1 unit, hypotenuse will be 2 units, and by using Pythagoras theorem, we will obtain that adjacent side here is square root of 3. Thus, sine pi over 6, that is 1 per 2, opposite side per hypotenuse. Thus, minus sign here, thus minus half, times cosine pi over 6, that is adjacent per hypotenuse, square root of 3 over 2, plus 8 times minus cos pi over 6, that is square root of 3 over 2. Now here is 2 square root of 3, this one is minus 4 square root of 3, thus 2 square root of 3 minus 4 square root of 3, that is minus 2 square root of 3. Thus the exact gradient of the curve at A, that is minus 2 square root of 3. Question C, find the exact area of the shaded region. Thus this is the shaded region. Thus that is the region bounded by this curve, the curve of this equation. Here is bounded by y-axis, and here is x-axis for x from 0 to 7 pi over 6. Thus the area of the shaded region, that is equals integration from 0 to 7 pi over 6 of equation of this curve, that is 4 sine squared x plus 8 sine x plus 3 dx. Now here we have double angle identities, cos 2x equals 1 minus 2 sine squared x, or sine squared x equals 1 minus cos 2x over 2. Because we cannot integrate directly sine squared x, thus first we have to substitute sine squared x here by this one, 1 minus cos 2x over 2. Thus integration from 0 until 7 pi over 6 of 4 times sine squared x, that is 1 minus cos 2x over 2, plus 8 sine x plus 3 dx. Now 4 times 1 divided by 2, that is 2, plus 3, that is 5, and here 4 times minus cos 2x minus 4 cos 2x divided by 2, that is minus 2 cos 2x plus 8 sine x dx. Now the integration of 5 dx, that is 5x, integration of cos 2x, that is half sine 2x, but we have to here those 2 times sine 2x over 2, that is sine 2x, the integration of sine x, that is minus cos x, that is why here is minus 8 cos x, for x from 0 to 7 pi over 6. Now first substitute the upper limits of the integration. Those 5 times 7 pi over 6 minus sine 2 times 7 pi over 6, that is 7 pi over 3, minus 8 cos 7 pi over 6 minus this equation. X is substituted by lower boundaries, thus 5 times 0 minus sine 0 minus 8 cos 0. Now that is 35 pi over 6. No, the sine 7 pi over 3. 7 pi over 3 actually, thus I illustrate here. If we rotate counterclockwise from x-axis until 7 pi over 3, that is more than one complete rotation actually. Thus the position is here, and the angle between this position and x-axis, that is pi over 3. Thus this is the basic angle. Thus for cos 7 pi over 3, we can replace this, or that is equals sine of this basic angle, and then sine the first quadrant is plus, thus also sine is the same. Thus sine 7 pi over 3, that is sine pi over 3 equals sine pi over 3. And here cos 7 pi over 6, 7 pi over 6, that is lies in the third quadrant, and the basic angle is pi over 6. But here is in the third quadrant cosine is negative, that is why we can replace this one, cos 7 pi over 6 by minus cos pi over 6. Minus, this is 0, 0, and cos 0 is 1, thus is minus 8, thus this the value of this one, that is minus 8. Now again, here we have two special angles, pi over 3 and pi over 6. The ratio of these trigonometric ratios for special angles we can obtain by using this right angle triangle. Thus, if this angle is pi over 6, this is right angle, and if the opposite side is 1, this hypotenuse will be 2. By using Pythagoras theorem, we obtain this is a square root of 3. Thus, if this angle pi over 6, this angle will be pi over 3. Now, sine pi over 3, sine pi over 3, that is this is opposite side, this is the hypotenuse, that is square root of 3 over 2. That is why sine pi over 3 is square root of 3 per 2. And minus cos pi over 6, that is this is pi over 6, the cosine is adjacent per hypotenuse, square root of 3 per 2, minus times minus plus 8. Now this is 35 pi over 6. This is minus square root of 3 over 2 plus 4 square root of 3 plus 4 square root of 3. Thus that is 7 square root of 3 over 2 plus 8. Thus this is the exact area of the shaded region, that is 35 pi over 6 plus 7 square root of 3 per 2 plus 8 square units. Now, that's all for this question today. See you in the next video. Thank you.